Hello, Precalculus students. Today's notes are on probability, and we're just going to do a very brief overview of what probability is all about. You could study probability for years, take entire courses just on probability, but let's just take a look at some of the basics of probability. So first of all, definition of probability. Now, first you'll see this notation. This does not mean P times A. It's not a function P of A. It's a probability of an event. So you might write something like this: the probability that you roll a die and get a 5. You'd write this way. Well, it equals the number of possible outcomes over the number of total outcomes. So for example, on a die, there's 1, 5, there's 6 total sides, so the probability you get a 5 is 1 out of 6. It's always something between 0 and 1. You cannot have a probability greater than 1 or a negative probability. 0 is something that's impossible. 1 is a probability that always happens 100% of the time. And then if you ever see something with a prime notation, that means a probability that something does not happen. So for example, if I write this means the probability that you roll a die and you do not get a 5. Well, we could say 1 minus 1/6, or you could just say, hey, there's 5 sides on the die that are not 5s out of 6 total sides. So the probability you roll a die and do not get a 5 is 5 out of 6. So let's take a look at a few examples here that use probability. So on this next example, what is the probability of picking an ace from a standard deck of cards? Well, we could write it this way: the probability of getting an ace. There are 4 aces in a standard deck. There are 52 cards in a standard deck. And there's your answer. Now, it is okay to simplify a fraction with probability, 1 out of 13. It's also okay to write this as a decimal. However, to be honest with you, I prefer this original answer. Here's why: because with this answer you can see exactly where the numbers come from. There are 4 aces out of 52 cards. There are cases where a simplified fraction or a decimal are preferred. However, in this case, I like to see where those numbers come from. Now, let's get a second example here. This one's going to take a little bit more work. So what's the probability of rolling 2 dice and getting a sum of 10? Now, what makes this one difficult is this idea here that we're rolling 2 dice. If you're just rolling 1 die, these problems are relatively easy. With 2 dice, it's a little bit more complex. So here's one way you could do this. One way you could do this is to make a table of values, and within this table you're going to write every single possibility if you roll 2 dice. So along the top I'm going to put the numbers 1 through 6, and along the left side I'm going to put the numbers 1 through 6. And within this table we can write down all the sums you could get if you roll 2 dice. Okay, now I'm not going to fill out the table completely. If we had a number of these problems to do, we'd fill out the table completely, we'd use the table, but basically what the table's good for is it lists every possibility. For example, if you roll a 1 and a 1, a 1 and a 2, etc., etc. Now I'm just going to skip down here to this lower right-hand corner, because using this we can see that the only ways possible that you can roll a sum of a 10 would be if you get a 6, then a 4, or a 5 and a 5, or a 4 and a 6. Notice 4 and 6, 6 and 4, 2 different cases. So there's 3 total possibilities out of, it's a 6 by 6 table, 36 total cases. So your probability is 3 out of 36. Okay, let's continue. So in this next case, the probability of independent events. So probability of A and B, what does that mean? Well, in this case you might talk about something, what's the probability of rolling a die and getting a 3, let's say, and flipping a coin and getting a tails? So 2 things have to happen for this probability to be true. To figure this out, we find the probability of the first case times the probability of the second case. And here's the notation we see for this. This is called the intersection of A and B. So here's an example of this, and actually it's exactly what I read before. Probability of rolling a die, getting a 3, and flipping a coin and getting a tails. Well, the first probability, rolling a die and getting a 3, there's 1 3 out of 6 sides. Since it's an and problem, we're going to multiply our probabilities. Flipping a coin, getting a tails, there's 2 sides. One of those is tails. So top times the top, bottom times the bottom. There is your probability. If you did both of these things, that's the probability that you would get a 3 and a tails. Now let's see how that's different from this next kind of problem. What if we change the problem and say, what's the probability of rolling a die getting a 3 or flipping a coin and getting a tails? So on the previous one, let's say you're playing a game and you win the game if both things happen. You roll a die, get a 3, and flip a coin and get a tails. In this case, you win the game if either one happens. You roll a die, get a 3, or you flip a coin, get a tails. So in this case, this probability is going to be higher. You're more likely to win the game because either thing could happen. Now, if you have an OR problem, what we do in this case is find the individual probabilities and then add them together. Now, we also have to subtract the probability that both events could happen. Here's why. That probability is counted in this first case, it's counted in the second case. Basically, you're double counting the chance that both events could happen. So you have to subtract that. Now, if you see this notation, this is the union of A and B. Okay, so let's look at that same problem. I changed only one word. I made this OR. What's the probability of rolling a die and getting a 3 or flipping a coin and getting a tails? So it's exactly what we had before. 1/6 is the first probability, 1/2 is the second, but now that word OR tells us let's add these probabilities. Now if you just add these two together, you won't get the right answer because you're overcounting one of those cases. In the case you're overcounting, if both things happen, you roll a die and get a 3, and flip a coin and get a tails, that case is counted here, and it's counted here. So since we're double counting, we need to take that away. Well, how do we know what to take away? We take away the answer we got to the previous problem. We take away the probability of both things happening. Okay, so to complete this, I'm going to get a common denominator here. And we end up with a probability of 7 out of 12. So 7 times more likely than the previous problem. Okay, let's look at one last example, then we'll call it a day for our notes. So last example, what's the probability of drawing 4 aces from a standard deck of cards? Now what makes this difficult is that we've got multiple things going on here. So if you ever see this happen, let's simplify our problem and say, what's the probability of drawing 1 ace? Well, there are 4 aces in a deck of cards. There's 52 cards. Now, if that's all the problem said, we'd be done. However, the problem doesn't say 1 ace, it says 4 aces. So let's extend what we have done. We need to draw 1 ace and a second ace. Now, it's an and problem, so I'm going to put a time sign. And now, what's the probability of getting another ace? Now, careful here, because one of the aces is already picked. So there's 3 remaining. Careful on the bottom as well. One of the cards is already taken, so there's 51 cards remaining. Oh, okay, so now I kind of think we can see the pattern here. So here's our first ace, second ace. We need a third ace. There's 2 remaining out of 50. And we need a fourth ace. There's 1 remaining out of 49. So if we multiply the top times the top and the bottom times the bottom, we end up with 24 out of about 6.5 million. So really very unlikely that I were to deal you 4 cards, you'd get 4 aces. Okay, so that's some of the basics of probability. That wraps up what we need to know. There are some practice problems for you in your textbook, so take a look at those, see what you can do, and let me know what questions you have on those problems.